Welcome everybody to this first YMFC 3D project video. In this video I'll show you the hardware that I use for this project. And I'll take you through the building process step by step and make all documents available for download. So let's start with the hardware. Now the first thing that you need is an Arduino. This is the easiest option to start with and gives you plenty of overhead to further develop your own multi-copter flight controller. Now you could use an Arduino Pro Mini for this. The problem is that the power supply on a Pro Mini is an MIC 5205. Now this regulator can only supply 150 milliamps with proper cooling. So to keep things on the safe side, I will be using the Arduino Uno for this project. The next thing that you need is a gyro. Now I've chosen the L3G4200 from ST Microelectronics. Through experience I have found that this gyro performs very well. The one that I use is this breakout board from Parallax. Now you could get cheaper breakout boards if you Google around on the internet. But please note that not all gyros are 5V compatible, so you might need a level converter to convert your data signals. I'll put a link in the description for more information about this subject. Another option is this L3GD20H breakout board. The communication with this gyro is the same as the L3G4200. Only the address of the device is different. This is covered in another video where I'll explain the communication with the gyro. For controlling the quad, you need a standard receiver with a minimum of 4 channels and a corresponding transmitter. For controlling the motors, 4 electronic speed controllers, or ESCs, are needed. Now please note that these are not standard ESCs that you find on airplanes. The ESCs that you need for this project are fast reacting ESCs that are specially designed for multi-rotors. And for connecting the wires to the Arduino, I recommend to use pin headers like these. And last but not least, you need a quadcopter frame and 4 motors with props. Now there's a ton of information to find on how to build your own quadcopter frame. Because of that, this will not be covered in this video. This is the schematic of the quadcopter. I'll post a link in the description so you can download it. First we start by connecting the wires to the gyro. The connections that you need to make are power, clock and data as shown here. For mounting the gyro on the quadcopter, I'll use double-sided tape. Now it's not necessary to use soft double-sided tape to reduce vibration. Mount the gyro with the wires to the back of the frame. If you have another L3G4200 breakout board, make sure that the dot on the gyro is pointing to the left rear of the frame. For my own setup, I use spacers so I can mount the Arduino Uno on top of the frame for easy access. Now of course you are free to build your own setup and mount the Arduino Uno any place you want. Now that we have our hardware ready, we can start connecting the wires to the Arduino. For this, I use solder with a flux core. Now flux removes small amounts of contamination, so you can get a better connection. To keep things easy, I pre-solder the pin headers and the wires. Now use a piece of heat shrink to isolate and protect the connections. Now you can easily solder the wires to the pin headers on the Arduino. the battery will discharge during flight, and as a result, the motors produce less power. In other words, the motors react different when the battery voltage is dropping during flight. Now, to compensate for this behavior, the controller needs to know the battery voltage. Now, this can easily be done with a voltage divider as shown in the schematics. The voltage divider in the schematic is only suitable for 3-cell LiPo with a maximum voltage of 12.6 volts. Now, if you are going to use a 4-cell LiPo, you need to recalculate the resistors. The result should be as high, but not above 5 volts on the analog input with a full battery. Connect the resistor to the V-in and ground of the Arduino Uno and connect the resistor connection to the analog input 0. The USB port of your computer provides power to the Arduino Uno while programming. To prevent that the USB power is feeding the ESCs and motors, a diode needs to be placed as shown in the schematics. The signal wires of the ESCs are connected to port 4, 5, 6 and 7 as shown on this image. Channels 1, 2, 4 from the receiver are respectively connected to port 8, 9, 10 and 11 as shown on the schematic. For a status indication and low battery warning, it is always useful to connect a bright LED. The Arduino outputs can provide 40 mA. This makes it possible to directly connect an LED to a digital output of the Arduino. Now, according to the schematics, the LED is connected to port 12 with a current limiting resistor. And that's it. We just built our hardware setup. In the next video we'll start writing the program for the Arduino Uno and test the receiver inputs. Now don't hesitate to leave a comment or a question and subscribe so you don't miss the next video. So thank you for watching and see you next time.